At the heart of galaxy M87, 55 million light-years from Earth, lurks a monster. An object so dense and powerful that it devours light, matter, and even time itself. A supermassive black hole with the mass of 6.5 billion suns. But what makes these cosmic behemoths truly mysterious isn't what they swallow. It's what might exist beyond their event horizon. Recent breakthroughs in theoretical physics suggest something so mind-bending that it could redefine our very understanding of reality. It all begins with a deadly dance between matter and energy. When a massive star, at least 20 times heavier than our Sun, exhausts its nuclear fuel, the delicate balance keeping it alive shatters. Its core collapses under its own weight in mere seconds, while its outer layers are violently ejected in one of the universe's most spectacular events, a supernova. But this cosmic drama is just the prelude. If the remaining core is massive enough, not even the strong nuclear force, one of the four fundamental forces of the universe, can halt the collapse. Matter gets crushed into an increasingly tiny volume until gravity becomes so intense that nothing, not even light, can escape its grasp. Yet stellar death isn't the only path to creating these cosmic predators. Almost every galaxy harbors a supermassive black hole at its center, millions or billions of times more massive than our Sun. Their origin remains one of astronomy's greatest mysteries. They might have formed from the direct collapse of enormous gas clouds in the universe's infancy, or through the mergers of smaller black holes. Our own Milky Way's central black hole, Sagittarius A star, weighs as much as 4 million suns and continues to grow, consuming gas, stars, and even other black holes like a cosmic vacuum cleaner. A black hole isn't simply an object in space. It's a region where gravity becomes so extreme that it punctures the fabric of space-time itself. Imagine stretching a rubber sheet and placing a bowling ball on it. The sheet curves, creating a depression. Now imagine that depression becoming infinitely deep. That's closer to what a black hole does to the fabric of space and time. The event horizon, that famous point of no return, isn't a physical surface you could touch. It's a mathematical boundary where the escape velocity exceeds the speed of light. Think of it this way. When you throw a ball upward on Earth with enough force, it can escape Earth's gravity. But at the event horizon, you'd need to throw something faster than light to escape, which is impossible according to Einstein's special relativity. It's like trying to run up a down escalator that's moving at the speed of light. Just outside the event horizon lies one of the most extreme environments in the universe. Here, the differential gravity is so intense it causes spaghettification. And no, astrophysicists didn't choose this name just to make their papers more interesting. Imagine holding a slinky vertically. The gravity near a black hole is so strong that, like that slinky, any object would be stretched vertically and squeezed horizontally. A human would literally be pulled apart atom by atom, like cosmic spaghetti in nature's most violent pasta maker. But there's more. Black holes aren't static. They spin, and their rotation drags space-time along with them in a process called frame dragging. Near a rotating black hole, space itself swirls like water circling a drain. This creates a region called the ergosphere, where standing still relative to distant space is impossible. Space itself is in motion. It's like trying to stand still in a cosmic hurricane, where the winds are made of space-time itself. One of the most profound mysteries about black holes concerns the fate of the information they devour. According to quantum mechanics, information, the fundamental nature and state of every particle, cannot be destroyed. But what happens when it falls into a black hole? Stephen Hawking proved that black holes aren't completely black. They emit a faint thermal radiation, now known as Hawking radiation. Imagine a pot of boiling water. Occasionally, water molecules have enough energy to escape as steam. Similarly, through quantum effects, particles can escape from black holes. But this radiation appears completely random, seemingly erasing all information about what fell in. This creates a fundamental paradox that has puzzled physicists for decades. The solution might lie in string theory and the holographic principle, and we can understand this through some everyday examples. Think about a credit card hologram. Although the image appears three-dimensional, all the information needed to create it is stored in the thin metallic layer on the card's surface. Black holes might work similarly. Consider a burned book. At first glance, all the information in its pages seems lost forever. But if we could analyze every particle of ash and smoke with infinite precision, we could theoretically reconstruct the original content. Black holes might do something similar. Instead of destroying information, they might encode it on their event horizon's surface, like a cosmic hard drive. It's as if everything falling into the black hole gets scanned and preserved in a two-dimensional format. This idea has even deeper implications. It suggests our entire three-dimensional universe might be like a vast hologram, with its information actually encoded on a distant two-dimensional surface. Imagine the most advanced virtual reality game possible. What we perceive as depth and volume might actually be generated from information stored on a cosmic memory card. But what really lies beyond the event horizon? Recent theories suggest scenarios that sound like science fiction, but are rooted in serious physics. The classical view predicts a singularity, a point where density becomes infinite and known physics breaks down. But many physicists believe this is just a limitation of our current theories, like trying to use a street map at atomic scales. A more exotic theory suggests black holes might be wormholes, tunnels through space-time connecting different regions of the universe or even parallel universes. This idea, once relegated to science fiction, is gaining credibility in the scientific community. Think of the universe as a sheet of paper. A wormhole would be like a tunnel connecting two distant points on the sheet, creating a shortcut through space and time. In 2020, Roger Penrose won the Nobel Prize in Physics for his work on black holes, mathematically proving they're a direct consequence of Einstein's general relativity. But his recent research suggests something even more radical. Black holes might be the engines of a cosmic cycle of death and rebirth of the universe itself. Latest computer simulations suggest that inside a black hole, beyond a certain point, the laws of physics might flip. Time might become space, and space might become time. In this region, the singularity might not be a point at all, but a new region of space-time with its own physical laws, like entering a new universe with a completely different rulebook. The implications of these theories are staggering. If each black hole contains a new universe, and our universe itself might have formed inside a black hole of a parent universe, then we live in an infinite cascade of universes, each born from the gravitational collapse of another. This theory of eternal inflation suggests universe creation never ends. Each black hole might be the seed of a new cosmos, with slightly different physical laws. It's like a cosmic natural selection, where universes that produce more black holes generate more baby universes. Black holes reveal the limits not just of our understanding, but of reality itself. They are places where matter, energy, space, and time merge in ways that challenge our imagination. But perhaps their true nature is even more extraordinary. They might be the gateways through which the universe eternally renews itself. As we contemplate these mysteries, a question emerges. If our universe was born from a black hole, what existed before? And more importantly, what might exist beyond the black holes we observe today? If these revelations about the mysteries of black holes have expanded your mind's horizons, hit that like button and subscribe. There's a universe of mysteries out there waiting to be explored, and this is just the beginning of our journey through the frontiers of reality. Safe travels, explorers.